Hi, I'm Julia from Avalin, and I work in AI. And I'm very thrilled to be here this evening with you. I would like to share a bit of my story, my background, some alternative paths to AI, perhaps, and advocate for a more multidisciplinary approach to AI. So I'm trying to cater for the AI curious who is new or doesn't yet work in AI, but it's also for you data scientists and software engineers that I know might be here. So my background is from computer science, and I've always been drawn to AI. Within computer science, I majored in something we call human-computer interaction, which is a multidisciplinary field within computer science, blending from sociology, psychology, etc., and using this to design for good user experiences. Whenever I could, I took courses in language philosophy, computational linguistics, which is what we use in natural language processing, NLP, any machine translation, chatbot, etc. I took courses at the psychology department in cognition, perception, etc. After graduating, I was not sure how to enter the field of my interest, which is AI, or is AI. The sort of natural path for me was to become a user experience designer. And although I always have users in mind, this didn't feel like the path for me. So a short timeline of my professional life. I started doing web development, and then this role called inventory estimator showed up. I got to do forecasting and business intelligence development. I then worked as an analyst, again, more BI, business intelligence stuff, but also Python development. I got to do clustering and many things otherwise used in machine learning and AI more broadly, but no machine learning models. As a consultant at Inmeta, I've been able to do more of the same in many different fields, including agriculture, aviation, finance, etc. And my next venture is with VR. Okay, so we all know this path to work in AI. You study physics, math, maybe statistics. You learn Python programming and become data scientist and make a lot of money, as some people. Yeah. I'm here to tell you that AI needs you almost no matter what your background is. Because as AI-infused systems become more and more widespread, your unique perspective is very much needed. And let me tell you why. A bit of what software engineering has taught me. So as a traditional data scientist with the background that I just described, chances are you know next to nothing about software engineering, actually. And you may work, you don't know the truths that software engineers are kind of taught very, are taught. For example, that estimating tasks is very hard. It's well documented that software development projects are approximately 30% above budget, at least. Maybe you work within sprints and have stand-up meetings, but if you don't know where these terms come from, they're just silly words and maybe even annoying meetings. And if you don't know the history of the agile development movement, you don't know why we moved away from the waterfall development process model. I know firsthand that this lack of historic insight leads to using the waterfall development process model. And surprising to no software engineer, this leads to problems. So if this is true for you, I urge you to go to agilemanifesto.org, read it. It's literally just one page that's been static since 1997 or whatever, and take a little software engineering history lesson. What design has taught me. So if you're a data scientist or a software engineer, chances are you don't have formal training in user-oriented design. And maybe you've learned the hard way that customers or users cannot be trusted to hand over requirements for you to implement. Start implementing the requirements, and more often than not, it was not what they wanted. And if it was what they wanted, then maybe it was not what they needed. As a software engineer working alongside data scientists, I see this all the time. And if I can be candid, data scientists generally test too late. This is my personal opinion. And I'm not talking about testing if the program works, but if it does what it's supposed to do. I once worked alongside two very excellent data scientists. They had been tasked with making a predictive milk production model for Norway. So they had gotten the requirements. They went to work and came back with a model that could accurately predict milk production per municipalities in Norway per the requirements. But as it turns out, for many reasons, this was completely useless and not what the customer had wanted. The customer had assumed that it was obvious to anyone that this had to be done on farmer level, but that was not obvious to the data scientists. If you're a data scientist, you're also a software engineer, and you're a designer to a certain extent. It doesn't mean that you have to start making wireframes, but maybe be aware that what you make up for in math, you may lack in design thinking. Lending from anthropology for data gathering and being user-oriented can really literally save you years of your life, at least your professional life. So I urge you to watch the very classic IDEO on 60 Minutes. This is true for you. And to check out Don Norman's also very classic book, The Design of Everyday Things, and most importantly, not only ask, how do we do this technically, but why do we do this? And should we even do this? What psychology has taught me. So many believe that psychology is about feelings and Freud. While that's partly true, absolutely, psychology is a huge field, increasingly intersecting into biology. I find it useful to have studied perception and cognition as a systems developer because it's about how humans process information. It's also useful to know what little we know about memory and how the brain works. One of the most buzzwordly machine learning algorithms or paradigms out there, neural nets, was inspired by a theory of how the brain works. But this is a 1950s theory that was built upon in the 80s. And I think it's necessary, actually, as a data scientist, to know that a lot has happened in the brain sciences since then. Because, yes, more powerful computing has given us the AI boom that we're in right now, and has made it possible to implement neural nets that we couldn't before. But we also know a lot more about the brain work. So do we know that they're the best, or even a good model for learning? Maybe there's better models that we should be inspired by at this point. At San Jose State University, my perception professor was working in a design team at NASA. He now works at Google. This is to say that engineers need more than math and logic to make good systems, or in other words, we need more than engineers to make good systems. But, whoops. Oh no. There is a missing slide here. I wanted to, you can't see, but I wanted to talk a little bit about what linguistics has told me. So, I mean. So, Bayes' theorem is very familiar for anyone who has some experience with statistics or linguistics, computational linguistics, whatever. In NLP, natural language processing, it lets us, Bayes' theorem, lets us find the probability of a word given another word, for example. However, machine translation is really not a solved problem. I'm sure you've all tried Google Translate and it doesn't always work great. Natural language processing turns out to be extremely hard. Written language might be our best, most genius invention, but we don't really have a manual, or it's been lost. We can tag every last word in every language in the world, and still we're not done because the language is alive and it's always evolving. My point is that natural language processing uses advanced statistics such as Bayes' theorem to predict words and sentences, but it's very hard, if not impossible, to predict words the machine doesn't know. And this problem is not only a conundrum for natural language processing. In any predictive system used by retailers or anyone really, it's really hard, if not impossible, to predict whether customers would be interested in buying product X if that product was never in stock. At least just by looking at the data. For that, we need to look outside the data. And if we need to look outside the data, it means that Bayes' theorem, for example, can only take us so far. And maybe we need to look at Pierre Bourdieu's theory of capital and class distinction. Maybe that can inform us more about human motivation and behavior than Bayes' theorem. And we need to go to sociology in that case. So, yeah. Certifications are cool, but many people have seen this very famous quote by Bertrand Russell. It's used all the time. Any logician knows Russell's contribution to logic. Many knows he was an outspoken atheist, but did you know he was an avid pacifist trying to avoid World War II? Obviously, he didn't succeed in this, but curiousness outside his own field made him able to look at the world outside of mathematics. As a developer, we all and constantly feel the pressure to get ever new technical certifications, and that's important. But if you're an engineer, come from STEM or really anything other than the social sciences, chances are that although you work with data, you haven't had the chance to study how or why bias in our data sets compound. So I'd urge you to take an ethics class next time, because now there's really countless real-life examples in production in systems out in the world today to show how grim the state of ethics amongst engineers are. I mean, self-driving cars that are less likely to classify dark-skinned people as humans. Yeah, etc. So it's just not enough to make models that work. Maybe we have to take some time out of our year to understand the implications of the systems we have built. So I know that everyone can't learn everything. It's no longer possible to be a Renaissance man, and I'm not trying to make people with a PhD in physics feel bad, or maybe a little bit. I should definitely know more physics because I know it can inform us about how to make better systems. Something, for example, Mark Burgess writes about in Smart Spacetime, how information challenges are these about space. My point is that we need to be humble to the fact that there's many holes to our knowledge. We should want to diversify the background of the people in our teams for this reason. It's not enough to know data structures and machine learning algorithms. When we're tasked with building infrastructure everyone in our society will come to depend on. It's not just an engineering problem. So lastly, to the young aspiring data scientists out there, I'd like you to be confident that your background is valuable. We need art, we need social sciences, we need your perspective in AI. And specifically, we need you to speak on the things we don't know and thus can't think of. Do you learn to code? Absolutely, learn to code. Python's own tutorials at python.org might be a good place to start, or W3 schools. And learn concepts. Relational algebra is the basis for databases. Linear algebra is used in most machine learning algorithms. Bayes' theorem is probability theory and used in many statistical systems, prediction, etc. And Khan Academy is excellent for this. Take Andrew Ng's courses at Coursera, follow him on Twitter, whatever. But really importantly, don't forget, downplay or be ashamed of your background, because it's needed. And for anyone who knows Texas Hold'em poker, your background is the kicker to your ace.
Thank you so much, Julia. You'll get an applause at least from one that has the microphone turned on. Really awesome. Thank you for sharing those thoughts. And I think there's a couple of questions for you in the chat. So if you have time to answer those as we go along, that would be amazing.
Yeah, I will try my best.
Yeah, and we might also ask you something at the end. And also, you had a lot of great links and a lot of names that at least I need to learn more about. So if you can post some of that also in the chat, at least I would appreciate that.
Yeah, I'll do my best to share. Good stuff.
Thank you so much.